For day 5, we're going to talk about 10.2J, which is distinguished between a two-sample versus a matched pairs. And I'm going to have you try these 8 problems on your own first to determine, what do you think? Should we keep it as 2 separate samples, or should we combine it and do matched pairs? This is just good practice. So if you haven't done this yet, please do the assignment related to these 8. And again, I would say let's just highlight the first thing, which is point A. And if you want to dive more into comments B and C, which talks about what's the variable to measure and give an appropriate design or sampling, you can do that. But for our purposes, we really just want to focus on, do we keep it as 2 samples or should it be matched pairs? So pause this video and then replay it and see the appropriate answers and explanations. Okay, let's get started. Number 1, to test the effect of background music on productivity, workers at a t-shirt factory are observed. For 1 month, they had no music. For another month, they had background music. Each worker's t-shirt output is recorded. Is this a 2 samples or is it matched pairs? Hopefully you determined on this one that this is a great matched pairs setup. Each worker's output will be measured twice with and without music. The output that's going to be measured is the number of t-shirts sewn. And then if you want some more details about the actual setup, you can read B and C on your own. And this is good review, really, for Chapter 4. Okay, number 2. A random sample of 10 workers at Plant A is to be compared to a sample of 10 workers at Plant B to assess absenteeism due to illness. Well, matched pairs are 2 separate samples. In this case, it's an independent sample design. Even though the same number of workers is chosen, there's no apparent effort to match them by years or experience or gender. Keep them separate. These are 2 separate samples. There's really no way to match them up. For B and C, here's the relevant information of how you might set up this actual experiment to have it be carried out. Number 3, a new reading course was tried on 10 women. Each student's reading speed was measured before the course and again after attending the course for 8 weeks. Is this 2 samples or matched pairs? In this case, this is a pair design. Each woman's reading speed will be measured twice before and after the course. More information on what's being measured and how to set up the studies B and C. Number 4, to compare the average weight gain of pigs fed 2 different rations, 9 pairs of pigs were used. The pigs in each pair were litter mates. Matched pairs are 2 sample. This is a nice paired design. They were paired by litter weights, so they were matched on something that they had in common. So what you could do is you could actually have one pig take one method of weight gain and the other do the different rations, and you would subtract the difference of that matched pair. It's a great example of matched pairs where you have 2 subjects in 1 treatment to each subject. Number 5, to test the effects of a new fertilizer. 100 plots are treated with fertilizer A and 100 plots are treated with fertilizer B. In this case, they're independent samples. 2 distinct samples are taken, no attempt to make them match across the 2 samples. So this is just going to be kept as a 2 sample test, and we'll do the differences of those 2 samples. For number 6, a sample of upperclassmen at your school is taken. We wish to compare the average number of hours of sleep of juniors and seniors. Should you keep them as 2 samples or make them matched pairs? In here, it's independent samples, 2 distinct samples, juniors and seniors. Again, no attempt to make a match across from student to student. So let's just keep it as 2 samples and set it up that way. 7, a new fertilizer is tested on 100 plots. Each plot is divided in half. Fertilizer A is applied to one half and B to the other. What should we do here? Here, this could be a paired design. Each fertilizer is tried on the same plot, which has been subdivided. So if it's half and half on one plot, you can easily find the difference in that. So matched pairs would be a smart decision for this case. The number 8, Consumers Union wants to compare 2 types of calculators. They get 100 volunteers and ask them to carry out a series of 50 routine calculations. Each calculation is done on each type of calculator, and the time required for the calculation is recorded. In this case, a paired design is great. You have one subject in two different experiments, so calculator 1 and calculator 2. This will allow for you to control for different factors such as one's own unique speed on using the calculator. Now in your packet, you're going to see I have written down our kind of summary table of significance test. We have the 2 proportion z-test for the differences and the 2 sample t-test for the differences. I'm not going to walk through all of this again. I'm just going to recommend that you review your notes for how would you write the hypothesis, how do you check the plan conditions, what would you show for the due proportion, and how do you make your conclusions for those tests. This is a great review again about how to interpret the p-value. Conversely, I have a table for confidence intervals again for the 2 proportion, the differences in the interval, and the 2 means and the difference of that interval. Again, you're going to check your conditions, you're going to do your mechanics on that, and you're basically going to make your conclusion for the confidence intervals the same. Down here is a nice way to remind you how would you say confidence level. So remember, up here is the confidence interval. This here is the definition of a confidence level. So if you would like to take some time to write down how these compare, feel free to. But you do want to know the differences and the similarities amongst the 2 confidence intervals and the 2 tests.